Hello, Keith Rucker here at VintageMachinery.org. Guys, today I'm back to work over here on this John Deere cane mill that we've been working on for a while now. And I need to do some TLC to the rollers, the bottom rollers on this before we can really start putting it back together. And I'm to the point where I need to get this done. So what I've got here, there's two bottom rollers in here. I need to get these cleaned up, really inspect these journals really good. I looked at them when we took it apart and they looked all right. I think we're going to be able to get by without having to do any work to these, at least nothing major. And also I've got the bearings, the Babbitt bearing blocks that were on these. And the good news is that at least 3 out of the 4 bearings, the Babbitt bearings, are in good shape or appear to be in good shape. We're going to inspect them a little bit further. One of them, however, has issues. It looks like it got hot and kind of melted out and squished out. We probably just need to melt that one out and re-pour it. So that's going to also be something we need to look at doing today. So let's get in here, take a closer look at these, start cleaning them up, and coming up with a game plan on how to move forward on this. So these are the bottom rollers. You got journals on each side, and then there's also a little part here that a gear fits up on. Now, when I took these apart, I noted then that this mill has been worked on in the past, and someone came in and actually turned these journals down a little bit undersized, probably from where the original journals had just gotten scored up real bad and were in poor shape. Now, you know, ideally we would have a constant size all the way down from one end to the other here. This would all be the nominal size that it was originally. But in the grand scheme of things, guys, when you're dealing with Babbitt bearings, you don't have to have an exact size bearing because you pour your bearing to fit the journal. This is, in my opinion, an acceptable repair. I have done the same thing on mills and other parts in the past that have Babbitt bearings where the journal's been scored up. To keep from having to weld it up and turn it down and do a lot of extra work. And in this case, I think this is a fully acceptable repair, and we're going to roll with it. It's been working, you know, up until now. I don't really see a big reason to come in here and do this. Now, when I took these apart, I also sent these out for sandblasting. I did send these rollers out for sandblasting, but before I did, I wrapped up these journals with some paper and then wrapped that with some duct tape. Just so that we didn't sandblast these journals because these need to have a nice finish on them. They are a little bit dirty right now. I think the first thing I want to do is just take a wire wheel and get these cleaned up, and I can take a little bit better, closer look at them. Again, the bearings, this is the one that's kind of bad, and you can kind of see where it's kind of extruded out a little bit. I don't know, it looks like this thing got hot, had a lot of pressure on it, and it just kind of squeezed that Babbitt out of shape and out around. The other ones actually look pretty darn good, and I'm going to check them for fit a little bit better. I also want to measure all these to see if they're all the same size or whether a certain bearing has to go on a certain journal. We'll figure all that out here as we move on. I think I also commented on this when I took this apart, but one thing that I'm not too crazy about and that we're going to actually remove is that someone put grease zerks in these bearings where you take a grease gun and squirt grease on them. Guys, Babbitt bearings are designed to run in oil, not in grease. Grease is a death wish on Babbitt. Over the long haul, what will happen with the grease is number one, it doesn't really lubricate the bearing like it should. It's too thick. You need a thin layer of oil on these for them to properly do. Honestly, with the super slow speed that these are turning, it's probably not as big of a deal as it is on a higher speed bearing. But the other thing that grease does is you can get dirt and trash trapped in that grease, and then that will get into the bearing and it'll just wear the bearing out. Whereas oil will constantly flush it. You're constantly putting new fresh oil in here. That oil will be kind of wash itself out, and any dirt or grease or anything like, or dirt or any other abrasives that get in that bearing will be washed out. Whereas with the grease, it traps it in there and it can ruin that bearing over time. Again, these bearings are fairly fresh. They look to be in good shape other than the one. So I think we're fine, but we're gonna take these grease zerks out, clean these journals out, and take it back to where they're running in oil as they should be. All right, let's get the wire wheel out and do a little cleaning on these and see what we can come up with. All right, I have got these cleaned up now, and I've gone around and found the bearings that kind of fit each journal the best. I did measure them. These three journals are all within probably 20 thousandths of diameter of one another. They're all about, 2-inch, 100 thousandths. This one here, though, is about 50 thousandths larger than everything else, and it's kind of gnarled up a little bit. It looks like someone put a pipe wrench on this, and it looks like it's been ground on. It just never was. I don't think it was ever trued up, or somebody. I don't understand why, but it's about 50 thousandths oversized from the other ones. And I think what I'm going to do is just go ahead and put this on the lathe, get this one cleaned up, and the one that is kind of all misshapen and everything, I kind of suspect this one might have been on this journal, and that's maybe part of the reason why it's kind of wallered out. I don't know, but we will pour a new one to match that journal. I'm going to go ahead and mark these other ones kind of matched up where they go. And like I said, these are pretty much ready to go back on there. They just need to be painted, but they all kind of fit as they should. All right, let me go to the lathe, and we're going to get this journal worked on a little bit. The other ones, I think we're just going to leave them like they are. Got this over here on the lathe, and right now we're about 2-inch, 150 thousandths. These other ones, all the other ones are about 1-inch, 100 thousandths. So we got about 50 thousandths I need to take off that diameter. So let's fire up the machine. See what speed are we running. That'll work. Looks like we got it turning. Don't really see any major run out in that. Just set right up the way it was. All right. It's going to take about 30 thousandths off the diameter. Let's see, I got it in threading mode right now. Let me get my feed going. You can tell that's kind of out around a little bit, but I think it'll clean up fine. Let's see where we're at here. We're just barely even cleaning up. I don't even have enough of a cut yet to make a measurement on. Let me do another. I'll do about another 20 thou. All right, so we cleaned up except for just one little spot right there, but I got enough to measure across to get an accurate reading. And we're still got about 40 thousandths to come off. All right, just keep on working on this. I'll do another 20. We'll just sneak up on it. Yep, 20 more and we get there. So let me do another 20 and this will be a final cut. And there we go, one journal turned down the size. I did go ahead and just chamfer those ends while I got it. I think while I got it in the lathe, I'm going to polish this other side with some emery just because I've already got it spinning up and we'll have this one ready to roll. So I need to melt this Babbitt out of this shell so that we can start working on putting a new one in here. So I got my torch with a rosebud here. This Babbitt melts usually around 700-800 degrees, depends on the alloy, but doesn't take a whole lot. We'll just go ahead and get this melted out. Alright, that's all melted away. I'll let that cool down and we'll be ready to move on. I'm going to go ahead and pull that out just so it doesn't melt down in that Babbitt. And we'll let that Babbitt harden up. Let that cool down and get it cleaned up and see what we need to do about making a pouring mandrel to pour that. Since I've only got one bearing to pour here, and this bearing shell is kind of funny shaped, it's not really round where a collar will fit down in it just right. I think I'm just going to do this one and use the actual journal here as the mandrel. I'm just going to kind of rig it up, which is the way I do them a lot of times. If I got a bunch of them to pour and they're all the same, it makes sense to kind of make a dedicated pouring mandrel for it. But for just a one-off pour, what I'm going to do is I'm going to take some damming material here and I'm just going to kind of use it to position the bearing shell, kind of like such. I'm just eyeballing and centering it. Now I need to get some damming material back here behind there to keep it from coming out. We'll cap the front of this as well, and I think we'll be ready to pour. Just you know, these Babbitt bearings they're not rocket science. This is about as low tech as it comes, but they're effective and they work well. So let me get some of this damming material in here. All right, just kind of snaking some of this kind of back behind that. Just kind of mold it to the back. And I'm just looking to make sure that's on there straight. We will dam up the front of this. That looks pretty darn good. I'm going to get some Babbitt melting, and we'll get some heat into this shell, and we'll see if we can get that one poured. Got my Babbitt melting over there on the camp stove, so now what I want to do is put a little preheat on this journal and shell just so it doesn't freeze up too fast when I pour it. I just like to get these up a couple hundred degrees. Doesn't have to be super hot. Just enough to keep it from shocking when it goes in there and freezing off too fast. So give me a few minutes to get some heat into this and we'll pour that bearing shell. Here we go. I must be leaking because it's not filling up. All right. Let's see where all that went. Yep, we had a leak in the bottom. I'm going to have to set this up again. can see it coming out down here. I'll melt that back out and we'll try that again. I didn't get it sealed up on the bottom good. All right, we'll just melt that back in the melting pot. All right, let me get it set back up again. I'm probably going to have to let this cool down a little bit before I can handle it. So I'll be back and we'll try a second pour. All right, we're set up here for another pour. I think I about got my heat in there. I want to skim the top of this Babbitt, try to get those impurities that came up skimmed off. And we are ready to try it for another pour. Let's see how this one goes. Keep our fingers crossed. And that looks like it worked. We'll let that cool down. Turn off my heat here. We'll let that cool down. Looks like we got a good pour. This is still pretty hot, but it's cooled down enough. I think we can knock that bearing off. And yeah, that looks good. So I'm gonna let this finish cooling down and we'll be ready to, I think next I need to get all these bearing caps painted, paint the ends of the rollers, and it'll be ready to go back. This part will be ready to go back together. So let's do that. So I painted some of my parts yesterday. I let that sit overnight. I'm ready to go ahead and start putting the lower rollers in this mill. So I need to kind of take it back apart. I've just kind of got things kind of sitting here right now. Get this cross piece off the top. There we go. I have to get a strap and use the crane to pick this up. This is too heavy for me to pick up on my own. All right, I'm just going to set this down back here and probably just leave it set up. Now I need to pull this side out so that I can get the rollers in. Pull it up and let me go grab my rollers and we'll start putting this thing together. Well, I thought this was going to be easy. And I've ran into a problem, and I'm scratching my head a little bit here, kind of thinking about how I'm going to solve this problem, how it was originally solved, because I don't have the documentation or the parts to figure it out. So I have to kind of imagine things. Let me show you what's going on. So down here in the bottom, you got the bearing blocks. This is the one we just poured the Babbitt on. It slides in a little trough. It goes back and forth. The roller rolls in this, and it's adjustable by a set screw that goes through this right here. If you look up on the other side, there's a recess in there for a capture, a square head nut. There's a long set screw. There's another nut on the back side of this that you can jam it all together, and basically you loosen that up, you adjust it in and out. That puts tension on this roller and lets that slide in and get tighter and tighter. Of course, when you're feeding the cane through, it's pushing downward on this, so there's nothing pushing from the other side except the pressure of the cane going through. So my plan was just to put a set screw in there, and when I came over here to do that, I went and put a set screw in, and I'm running into something. It's blocked. duh, you got these posts, these bolts that run all the way up and down. These are very important. It's what holds the whole mill together. It pulls it all together and captures it in place. But they're lined up exactly where these set screws are supposed to go through. And it's clearly the set screw is supposed to go through because there's a hole on the back side here. I've got pictures of another mill just like this that I found on the internet. It shows set screws going through here. I've got pictures in my cane mill book, not on this particular model, but on some similar John Deere ones. It has bolts going through here. But you can't get a bolt through because of the block. Yeah, it's a head scratcher. You know, when I got the mill, it was set up just like this. There were these long studs going straight up and down. And I'm just sitting here trying to think, okay, how was this done originally? All that I can come up with, guys, is that originally there must have been a cast iron block that set down in here that you would bolt in from the bottom. It would kind of pull it together. There was a hole through it to allow the bolt to go through, and then there was a threaded hole in the top that you would put down in there. And there was a connecting piece in here. That's all I can come up with. I don't have any evidence that that's the way it was. When I got this mill again, that part wasn't there. When I got the mill, there was not bolts going all the way through. In fact, they had a set screw, or they had a nut in here, and there was just a bolt going into it, pushing against it. It was a pusher, but there wasn't a whole lot of room because that head stuck in there, so you had a very short travel in there. And I even remember making a comment when I took it apart. This isn't right. But when they assembled this mill before, I think they ran into the same problem. You couldn't get a bolt through. So they kind of came up with the compromise, which I don't think was the right way to do it. So, yeah, I'm scratching my head. I'm not sure what to do. Let me show you some pictures that I found so you can kind of see what we're talking about here. And, yeah, I think I'm just going to have to get creative and come up with a block to go in these. So just a couple of photos that I found again on the internet. This was actually on an auction site where someone was selling a John Deere Model 812 Hercules cane mill. The one we have is an 810. It's a little bit smaller than this one, but it's pretty much the same design. And you can clearly see the bolts down here with the set screws coming out of them. On that mill. I don't know who owns this mill. Like I said, this was on an auction site. The auction was completed a long time ago. And this is really the only photos that I've been able to find of another Hercules John Deere mill. Now, there are also John Deere made an Amazon mill. In fact, I've got one that I'm working on restoring as well. It's very similar. And here's a picture of the Amazon mill. The Amazon mill, though, is different in that you've got these little straps that come down on the side that pull down. So, you know, I could see on this one where these are actually pulling down and maybe not be something going all the way through them. I don't know. I don't think this mill did not have any blocks down in the bottom. I just don't know. If anybody out there is familiar with these mills and knows how it's supposed to be, by all means, shoot me an email, let me know. But I'm just kind of scratching my head here. I'm just not exactly sure how this thing originally went together. It's a bit of a mystery. But again, I think I can solve the problem by putting a block down here in the bottom that will allow a bolt to go through, because I think that's the way it's supposed to be done. That's the way it needs to be done to be able to properly adjust those bearings. So that kind of puts me at a standstill on this mill. Man, I was really wanting to get at least the main mill part assembled in this video and kind of be ready to work on the gearing system over there. But yeah, I'm kind of back to the drawing boards here, coming up with something. Unless I get some kind of really good concrete, hey, I've got one of these and this is how it is. I think what I'm going to do is I'm going to come up with a drawing. We'll make a casting that fits down in here, again, that bolts from the bottom, bolts from the top, and has a through hole through it. That will allow us to get this back together. I know that'll work. I don't know if that was the original solution, but I know that'll work. But that's going to require me going and doing some drawing, getting patterns made, sending it to the foundry, etc. And I know someone say, well, why don't you just make it out of a piece of steel? Well, steel just rusts, guys. It's the steel just on these mills. It comes apart too easily. I would rather have cast iron in there. It's going to hold up better in the environment that these mills live and operate in. So I really feel like that's the best option. You may disagree, and if you do, that's fine, but I'm the one that's doing it. So I'm going to do them out of cast iron because I think that's the right thing to do. But anyway, that's kind of where we're at. Yeah. As is not always uncommon around here, things didn't go exactly as planned, but we're headed in the right direction. We're going to get there. Guys, that pretty much wraps me up for today. I can't go any farther on this right now until we do some other things here. So that's a wrap. As always, thanks for watching. Please subscribe to the channel if you haven't already. Those thumbs up and comments are always greatly appreciated. Hit that bell icon up there to get notifications when new videos are posted. As always, a big, huge thank you to those who support the site financially through Patreon, PayPal, and YouTube memberships, all which are great ways to support the site. And with that, I'm going to get out of here. We'll catch you on the next video again. As always, thanks for watching.